Welcome back to Compiler Programming. A while ago I worked on this support for generic functions and I did a video about that. And today I want to work on improving that. Now, one thing that I've noticed once I started to use this stuff is that there is sort of always this typo. And it is kind of annoying from one side to always have to write this. And secondly, it actually causes some interesting issues as well, because when we are evaluating the function signature, we don't actually have any kind of actual value to look at. It's just evaluated struct, so we don't have what's internally called storage. And if we try to sort of use this value as we would use anything else, it might cause issues anyway. So I think the first change I want to do today is I want to make this be automatically the type instead of being a value. So you sort of will not have to use this type of stuff. So let's start with that. For that we need to go to ensure parameter descriptors. Yeah, that's the functions. And in here you can see we initialize this special value with no storage and the descriptor of the argument. And to clarify, the reason we did all this is so that we can refer to the types of the previous arguments in the next ones, which allows us to have this identity function represented like this and work with different types, as you can see in this test case, right? So we can call it with a string and we can call it with the number and everything is perfectly fine. Okay. So the change should be pretty straightforward to do. We're just going to replace this stuff. So the descriptor becomes the actual thing that we try to store. Like this. I guess like this, yes. And then here we need to say that this is a pointer to the descriptor. That is probably all that we need to do. Let's try. Okay, that causes some issues, but the reason it causes issues is because now we have these extraneous typos in here. So let's get rid of them. So should help with a few tests. Let's see if we improve our score here. Yeah, so we fixed 2 tests. Let's sort of see what else is there. I think the issue is here. Type of. So this is definition. Yeah, that's probably the issue. So I think now it looks much nicer, even though in your head you have to now remember that when X is used in the type position, then it refers to the type, and if it's used in the sort of name position, it's a name, but I think it's an okay thing to have, and this is where I would actually expect eventually I will implement much better syntax highlighting, and I think this is should solve this issue where you just see that this is like a type and this is a name. So I like this change. Okay, and then let's see what that does for us. Are there any more failing tests? Okay, we have 2 more tests that are failing. That makes sense. Yeah, and here it's the same stuff. And here we also need to do the same thing. So let's see how that goes. Looks good. Let's commit this. Episode 181. How would we call this commit message? I guess we say that define argument names as types when used in type position or something. Okay. Now that was just sort of something we can do quick. And now I want to do another interesting thing. So in here, we have this situation that we are using this x in the return. But I also want to verify that I could use x in sort of an extra argument position. So let's try to do this. Should support referring to the previous argument. Arguments type. Okay, so we should say x, y is x and returns x, and x plus y. My add, my add, and we are just gonna say my add of 10 and 20, or maybe. So we have 42 again. Let's focus on this test and verify if that works or it doesn't. Okay. So that is kind of interesting, but that's not really the issue that we are having. So let me actually do it this way. Because for generics, I still need to figure out if literal types maintain their original type or not when they are used in this context, but that's a separate topic to discuss. Okay, so this works, which is great. Let's run the tests again. Okay, all good, but it would be cool if this worked also other way around, right? Because there is no real reason why it shouldn't, except for deficiencies in the compiler maybe. So we say that x is actually the type of y and the y is 64. So this is a perfectly solvable sort of constraint situation, and it shouldn't be that difficult to solve. But I don't think that works right now. We can verify by running the tests, of course. And indeed it doesn't. Let's focus on the test so we can easier debug if we need to. And let's dive into trying to implement this. So yeah, the issue says undefined variable y. And the reason that happens is because we just evaluate this from left to right instead of treating it as sort of a constrained situation. Okay, well, how do we go about solving this? And the thing that I realized is that I already have a way to solve this kind of stuff, because whenever we have this double colon, that is actually a lazy definition and it's only evaluated when we try to access it. So why don't we just do that for the functions? We will define a fake scope. We will define each of the arguments as this kind of lazy constant. And then we will try to resolve each of the arguments in a separate pass. That sounds perfectly reasonable to me, and I think that might work. So how would that look like? Well, we already have a scope in here, which is good, but we need to figure out how do we deal with this stuff. So we need something like Lazy compile time expression. Yes, that seems like what we want. So let's take that and put it somewhere, I don't know, doesn't matter, in here. So we don't really care. Do we care if there is declaration? Yes, we do. Okay, so if there is a declaration, then we would just define that declaration. So we just say, let's say value star. Well, essentially, we will do this thing, I guess. So source range goes in here, and then yes, we create the value, and then we will also need to have an expression here, and we'll say that let's call it the lazy expression, and this is a symbol. Okay, the symbol will be param declaration symbol. We don't need to define this like this anymore. This actually needs to go in here. So we create like a single value expression for this, and for that we actually also need to say param value pointer, and all of this can just live in a temporary space, I think, because we don't actually care about this code. We can destroy it immediately after we are done actually resolving the types, right? So I think that's good. We locate a pointer, we do this. We'll need to put this into the pointer. We can actually do it this way, I think. Yeah, that sounds about right. And in the case where we do have an expression and not already known type, so this case is the case over here where we have explicitly type specified, and then we have this kind of case where we sort of don't. At least that's my understanding of my own code. Okay, so we have maybe type expression, fine. We don't really need to assert this, I think. Well, no, we don't. Here we'll just say a lazy expression is maybe type expression, right? That seems pretty straightforward. Okay, we define a lazy compiling expression, and it's a wrong scope, and it's also the wrong context. Needs to be like so. And now I don't think we need to change the return time, because by the time we get to return, everything is already sorted out anyway. So, and you can't refer to the return type for the purposes of type resolution. Like some type systems allow you to kind of do that, but it's basically we just don't. Once you go into the return value being a constraint on your, for example, overload resolution, you're in a lot of hurt, and your complexity sort of goes out like crazy. So, for example, C++ doesn't really do that. You can work around it in C++ with constructor and such, but anyway, I digress. The point is, by the time we get to here, we don't actually care, But what we do want to do is so this defines these kind of constraints, right? And we would like to actually get them out. So we need to have a second loop which actually looks up each of the um, types of the variables and stores them in here. So how would that look like? Well, we can just say that if we already have a parameter declaration, then we don't need to do anything. That's, yeah. But if we do have it, then we need to look it up, I guess. Value star type value is scope lookup force. Okay, we can steal this stuff, right? Context scope. Let's do const symbol star symbol is param declaration, basically this declaration symbol. And source range, we can steal this as well. Scope, not cope. Now we just need to get these two in here, and let's do it this way. So that gives us the like the value, but we still need to get the descriptor out of that. And what's it called? Value force type. Ensure type, yes. So it's called value ensure type. Okay, that's what we need. We just say the descriptor is this, and let's actually do it this way, I guess, so we don't accumulate errors. Like if we try to maybe even like so. Yeah, I guess it is like so. Okay, I'm missing a bunch of stuff. This is very easy. That's just semicolon, and that's mistyping, and yeah, I don't need the scope here. Value ensure type, item source range. So source range is this stuff, and then in terms of item, we have a type of value. Different const qualifiers. First of all, this needs to be temp context. Needs to be value star. Oops. Damn it. Star. Okay. Now we have a building. Let's see if we get lucky. Apparently we don't. Let's try to look at what is going on. I don't need this. So we have an alter somewhere. Okay. Where is that happening? Target descriptor, source descriptor. So, I mean, let's try it like so. So we still got to here. Interesting. So let me just try to. I don't want to keep those asserts, but I want to catch these happening earlier. Okay, now I'm sort of really confused. That's it's not what I wanted to do. Wait, no, yes, no, that's fine. That was there before. That does seem fine to me. That's very curious. So, all right, let's try this again and see where we are and what is going on. So we are trying to figure this out. We are trying to handle function call. Target expression is X type, Y type, and it returns type. Okay. And what seems to be the problem? X is impl and S64. No, that's the whole arc. Right. Okay. Make sure overload candidate. Maybe function info from value. So we have this overload info, parameters, and generic, declaration, descriptor. So that seems reasonable to me. Let's actually add it to the watch, and it's a bit easier to look at it here. Uh-huh. So this is where it doesn't work. So that's not cool. What is the name of this function again? Candidate, or rather not name. Source range, at watch 341. Ensure parameter. Okay, no. That I will not be able to catch it this way. I will need a nicer way to figure out the parameters. here. And now I want to know 1, 2, 3, 4, 5. So, okay, 1, 2, 3, 4. We have info, and we need some kind of condition to figure this out. Parameters, that seems like our one. Yes. Okay, so how can we catch this? Let's say parameters lengths, and we'll add this to conditions. Okay. Is this the right function? No, it isn't. Okay, whatever. 1, 2, 3. The function. Okay, so what does happen here? We go through this stuff. We get through here. Source range. Fine, fine. Oh, descriptor here is and it's an instance. Okay. We define it with a simple impl. Okay, we go in another round. Here we have a type expression. Type expression is type. Okay. In the first parameter, we oh, stupid. That was a very long thing. That was for nothing. It shouldn't be returned. It should be continue. Yay. Okay. Let's try again. And that was just it. So yeah, I spent 10 minutes trying to figure out a typo or like mistyping, I guess. And that is all we needed to do. And so that's perfect. Let's verify that all of this is actually working still. And it does, which is awesome. So yeah, this is what I wanted to do today, and I think it's pretty cool. So now we can sort of do it in any order. I guess one last thing that we can try to do, although it's not really connected to the thing that we're trying, but we should also verify that we don't go into infinite loop if we try to do this, right? So this is like the cool thing. I mean, for the arguments, it actually does have a solution. So this would be equivalent to something like t and t in other languages, but we are not using variables to denote types. So that exactly for the reason that we don't want to have, or I don't want to have full-on constraint solving. Like this kind of lazy lookups is just much simpler. It already exists in language, and it covers 90% of the cases, or maybe even more. But it still shouldn't go into infinite loop. Should not infinite loop when, or let's just say report an error when types document types refer to each other. Refer to each other. So here we would say we expect that to be an error, and we don't really need the function because we can't call it anyhow. Let's try to see if that works. And it does, because I already took care of it in the general case of this kind of resolving of lazy values. So we get it for free for the functions, which is awesome. So yeah, this is pretty cool. I'm excited to be able to express things that way. And that would be all for today. Thank you very much for watching if you stayed this far, and hopefully I see you next time.